Hey everyone, welcome to today's daily Leetcode challenge. Today we'll be solving question 1930, unique length 3 palindromic subsequences. So within a string, return the number of unique 3-letter palindromic subsequences. So given a string S, return the number of unique palindrome of length 3 that are subsequences of S. Note that even if there are multiple ways to obtain the same subsequence, it's still only counted once. So A can appear maybe multiple times, but as long as it's the same set of three characters, then it's considered to be the same, even if it appears somewhere else. So, okay. A palindrome is a string that reads the same forwards and backwards, so the two letters on the start and the end have to be the same. Subsequence of a string is a new string generated from the original string, so basically just an explanation of what a substring is, subsequence is. Example, ACE is a subsequence of A, B, C, D, E. Some examples here that indicate how many and how to count these three palindromic subsequences. We have the input string AA, BCA, and there are three palindromic subsequences, ABA, AAA, ACA. So here, actually, I guess it's not a very good example of the different subsequences actually being the same. For example, in this one, there are 4 B's, and so theoretically, you could have counted the subsequence BBB and this BBB as different palindromes because they are actually in a different place. However, it says here that even if there are multiple ways to obtain the same substring, it's still counted only once. So from the point of view of this problem, this BBB and this BBB are identical. Quickly, let's look at the constraints. There are a lot of characters. So we can't do anything that is that simply goes over all the possible subsequences, because I mean, to compare all versions, we would need to probably need something like 3 for loops, start, a mid, and a finish, and we would simply constrain each one of those 3 for loops by their left and right limit, and that would be n cubed. So that doesn't work. We need some more clever way of figuring this out, and what I'm thinking is there are only 26 letters in the alphabet, and we can already simplify our task a bit by knowing when does each one of those 26 characters appears first and appears last. What that would automatically do for us is eliminate having to search for a substring past its first initial occurrence. So for example, let's look at this guy here. If we know that this B is the first to appear in this input, then there's no reason to consider this B as the starting point for our substring. Why? Well, because this guy is guaranteed to be the first. Any other B that follows can only either be a mid character in the substring or the last. So what does that eliminate? That eliminates, for all 26 letters, that eliminates the laborious task of having to look through all possible combinations. Rather, we're only going to be looking at the left and the rightmost occurrence of each. Once we have that, we have pretty much a 26, which is a constant. So we will be repeating the search over the whole input string 26 times. So this turns into an O of n problem because the 26 is a constant. It's actually 26 times n comparisons, but I mean the constant gets dropped, so this turns out to be an O of n. What is actually then happening here? Let's begin coding. I'm gonna have a first occurrence with a default dict. This is a cool way to initialize default dicts with values that you specifically want. I'm going to assign this one to length of s because I'm going to be finding for the first occurrence, I'm going to be finding letters that occur prior, so there's going to be a min. For last occurrence, I'm going to be finding occurrences that are greater than, so I'm going to start with 0. Let's do it for I, C, in enumerate s. We should do something like if I is less than first occurrence of C, then first occurrence equals I. For last occurrence, I'm going to be seeing if there's an I that is greater than already what I have here. I'm going to print both first and last to see if I have the correct first and last occurrences. Last occurrence. Occurrence. All right. And I think we have this incorrectly filling out, or was it correctly? The first occurrence of an A is 0, first occurrence of a B is 2, of C is 3. Last occurrence of A is 4, B is 2, C is 3. Perfect, no, this is correct. What I need to do now is for each letter, for C in first occurrence keys, I need to see the start and the end of the first and the occurrence. And the last occurrence, this is, first occurrence C, last occurrence of C. This is going to give me the left and the right bound for, let's call this mid, in range from start 1 to end. I'm going to say if unique equals set. Let's have if, no, I will just simply append unique add s mid. And as a result, I need and then do plus equals len of unique return res. So what I did here was I went through the numbers or the letters in between the first and the last occurrence, and all the unique ones there are guaranteed to generate me a new palindromic subsequence. Why? Well, because the start and the end are already the same. I do this by identifying which character I'm going to be looking at. I'm very certain that this is the first occurrence and this is the last occurrence. And there we go. The last step is figuring out how many unique characters can we squeeze in between them, or can we find in between them. And I do that by simply looking at a set, going from start to end. By the way, not overlapping, so this is excluding the start, and by default, range excludes the end. And so then I add the character to a set and append or add the length of that unique set to res. Let's submit and see if we have everything. Well, sort it out. Beautiful. Are there faster solutions? There are. There are faster solutions. I wonder, though, if they are significantly different in implementation. I do not want anything more complex. And count palindromic subsequence. We have a res. We have a default dict for I and range of I, dict I, append for key and dict. I don't know if they're very intuitive. And to be completely honest, I'm pretty okay with the solution here, because I know that it's definitely doing an O of n rather than n cubed. So actually, yeah, I would probably recommend this. So on that note, thank you for watching. Please like and subscribe, and I'll see you tomorrow.